Hello, good afternoon all. My name is Farnaz Baksh, and the aim of my research project is to test if an effective robot can aid a student with learn helplessness. I began this research with the curiosity of asking the question, is it possible for an artificial intelligent machine to recognize human emotions, my emotions as a student? I discovered the problem is twofold. On one hand, we have the study of getting machines to understand us, our emotions. And on the other, I found that student emotional experiences impact their ability to learn. And in the case of students with learn helplessness, these experiences are manifested, which leads to student motivational, emotional, and cognitive deficits. Academic struggles may lead students to the feeling of learn helplessness, especially when it comes to the motivational deficits. Ideally, artificial intelligence applications such as affective robotics will be present in classrooms aiding students and teachers in the near future. The idea is to use the emerging technology of affective robotics to aid a student in overcoming their academic struggles and to influence a positive behavioral change. So, how might students interact with an effective robot? How might an effective robot help students cope with learned helplessness? Does an effective robot works? And can I create and test the multimodal approach? Turns out I can. Focusing on facial and speech as the only two emotional cues to measure, I've successfully used and implemented the Google AI kits. These kits communicate with each other on a server. The server was built using a Raspberry Pi 3 and a Flask framework in Python. Using these open source and affordable AI kits from Google, it provided me with extensive online support and fast deployment. So how does it work? The Vision Kit scans your face for some sort of emotional cue and gives a score to that emotion. At this stage of my prototype, it only recognizes two emotions. I program it to detect a positive emotion with a joy score of greater than 0.8 and a negative emotion of less than 0.1. This value is then sent to the server, which only receives the value if it's happy or sad. If you're happy, the voice kit responds with, "I'm proud of you," or some sort of motivational remarks. Whereas if you're sad, it asks if you want to talk about it. Both qualitative and quantitative data was aimed to be collected. However, this was before the COVID-19 pandemic. I had to modify my methodology. Nevertheless, I aimed to collect both types of data. Testing was now intended to be collected at a distance via video call. The main test was making sure that the artifact can identify faces on a screen and detect voice on a call. Sadly, the major change for my research was my target population. Even though I got UG students, I did not get students with learned helplessness since I could not administer the student behavior checklist procedure. I reached out to 15 participants. 11 were available and tested, of whom only 10 answered my questionnaire. Participants range from year 2 to 4. Apart from stable connection, we conducted all testing during daylight period and asked participants to be in good lighting conditions and environments where they can hear and respond clearly. Quantitative analysis. The first test I conducted with each participant was a demo test, where I tested for a positive emotion, example happy, and a negative emotion, example sad. Since I asked participants to hold their expression for a few seconds, the Vision Kit recorded a few values, of which I calculated the average to obtain a mean score. As you can see, the artifact was relatively accurate in these detection. The second test that was conducted, I asked participants 2 questions. What is your most challenging course this semester? And how do you feel about this course? A lot was said, and the Vision Kit had a lot to process. It captured many facial values, which I took the average of each participant and mapped it to the word they used to describe their feelings. The second question I asked was, what feeling or emotion do you associate with learning, and how do you feel about learning something new? There were a lot of mixed responses for this question, and the artifact had trouble recognizing most of these emotional cues. Participants were saying that they felt both enthusiasm and anger, or that learning is both fun and stressful. So the results are quite interesting. Qualitative analysis. Our qualitative data came from the user experience questionnaire, which consists of 26 scale questions. Participants were asked to complete this questionnaire after they interacted with the artifact. This chart shows the overall mean value for each of the 26 scale from the UAQ. Some of these features that stands out are how enjoyable or how understandable the affective robot was. Was it supportive or was it motivating? Let's investigate. Scale 11, which talks about obstructiveness or support, with 1 meaning obstructive on the extreme left and with 7 being supportive on the extreme right, we can see that 9 participants felt that the affective bot was supportive. Unlikable versus pleasing. 80% rate the highest score pleasing. Note that this falls under a scale of attractiveness, which I'll explain in a few. Motivating versus demotivating, with 1 meaning motivating on the extreme left and 7 meaning demotivating on the extreme right. This falls under the scale of stimulation. As I mentioned, each one of these scales was transformed. The transformed data from each individual response was categorized into 6 scales, namely attractiveness, meaning the overall impression of the product, perspicuity, meaning how easy it is to become familiar with the product, efficiency, meaning how easy it is to solve the task without the necessary efforts, dependability, how the control of the interaction by the user, stimulation, how exciting and motivating the product is, and novelty, how innovative and creative the product is. This can be further categorized into the following. However, in my research, I focus on attractiveness and hedonic quality, since it gives me more insight into the student behavior with the affective robot. This means the mean of these qualities were calculated. Overall, participants found the affective bot artifact to be quite engaging, friendly, innovative, a great form of support, and I love the idea of having a robot to help you study. There were many limitations due to the pandemic and with the artifact itself. The environment in which testing was conducted was not ideal, since the artifact is physical in nature. So humans has stronger emotional response to more human-like robot or tangible AI. And due to the pandemic, this was not possible for a participant to interact with the prototype itself. The current stage of the artifact is what I label as level 1, which is more of a bot rather than an AI. Thus, the inconsistency of the data and improvement is needed. The need to implement other facial expression and verbal response to our current artifact is one of the most recommended by participants. Of course, better need for environment for testing, maybe with the initial target population of students with learning helplessness, is another recommendation and future work. However, this do require planning ahead. In the future, I would love to actually test this in a classroom settings with many students at a time. To detect multiple emotional cues can also be considered. And lastly, explore other technologies to make a more advanced affective robot. So the ultimate question, did we achieve our objectives? Do I know how students feel about the affective robot while studying or as a companion? Yes, to a certain extent. But did we build a multimodal solution? Yes, we did. However, there are room for improvement when it comes to the accuracy and the efficiency. And given the limitation, and it was only one session, and the distance learning, we could have concluded that there was a positive, we could not conclude that there was a positive behavioral change, which is supposed to lead to a better academic performance. However, participants did say that it was motivating. Overall, did I answer my initial question? Is it possible for an artificial intelligent machine to recognize human emotions? My emotion as students? Yes and no. We still have a long way to go. Thank you.